Greetings and welcome to the presentation of the demonstration titled Distributed Multi-Agent System Fed with Telemetry Data for Near Real-Time Service Operation to be presented in OFC 2024. Near real-time autonomous operation is a special type of network automation that requires new technologies and architectures. In-band network telemetry in combination with distributed intelligence showed a great potential for efficient network diagnosis. Multipath routing can be effectively used to efficiently distribute traffic flows. A multi-agent system can be used to coordinate the operation of the flow agents and the telemetry system. The main objectives of this demonstration are to show the operation of a mask for near real-time control of an optical network, showcase the use of P4 switches with enabled in-band telemetry for collecting QoS metrics, and demonstrate the benefits of the dynamic reconfiguration of traffic flows based on metric. The following figure illustrates the presented scenario in this demonstration. Several traffic flows following a multipath routing strategy traverse a network through different packet nodes. The objective is to ensure per flow QoS finding the proper distribution of the traffic among the paths. To achieve that, metrics for the ingress router and in-band telemetry on the egress are collected. Decisions are made in basis of these metrics and policies are applied to each flow dynamically. The mask is composed of two different types of entities. The telemetry agent that receives the in-band telemetry captured by the P4 collector, processes the data per flow and sends the QoS metrics to the multi-flow agent. The multi-flow agent processes and takes decisions based on those metrics. The decisions are applied as policies modifying the amount of traffic sent through the different paths. The mask deployment consists of two VMs running Ubuntu 22.04 hosted on the UPC premises. VM1 runs the multi-flow agent while VM2 runs the telemetry agent, an InfluxDB instance and Grafana instance. The network deployment in the Canete SSSA RNO testbed consists of 5 connected native in-kernel P4 switches to create the packet network, an optical bypass based on a pre-programmed packet optical white box connected to an optical line system, a Spirent package generator used to generate traffic for 2 different flows, and a Juniper router connected between the packet generator and R1 used to introduce delay in some of the paths of the traffic flows. The connection between the two testbeds has been established using OpenVPN. This demo showcases the following elements: the in-band telemetry collection performed by the P4 switches and a P4 collector, the interaction between the mask components to coordinate the operation, and the path reconfiguration of the flows using a threshold-based approach using the collected metrics. A web interface has been deployed to facilitate the control and configuration of the mask components. In particular, we can modify the initial policy of each flow that describes the percentage of traffic that goes to each path. The other parameter that we can modify is the threshold that will trigger the path reconfiguration. In this case, this threshold is based on the average delay per path. The traffic generation is started in both flows from the Spirent Test Center software. Traffic metrics start being collected in the ingress router. Traffic measurements are sent from the ingress router R1 to the multi-flow agent manager component. These metrics include the packet count and bit count per flow. In-band telemetry with QoS measurements start being collected by the P4 collector. These metrics are sent to the telemetry agent where it will be processed by flow. The metrics include the maximum, minimum, and average delay and jitter per flow and route. Once processed, they are conveyed to the multi-flow agent. To simulate a congestion scenario, the traffic of the flows is increased. Delay metrics are showed as the congestion starts to impact the performance. The routing decision is made per flow and is applied to the R1 by the multi-flow agent. The policy represents the new percentage of traffic sent to each path per flow. Delay measurements from path 1 and 2 are no longer showed, and now they are displayed on path 3. This demonstrates the routing reconfiguration performed by the mask system and the metrics collected by the P4 switches. This concludes the demonstration. Thank you very much for your attention.